Okay, so the next question that we have is basically 71. The next question that we have is question number 13, I suppose, and you want to solve some equations. Solve the following equations. Now, number 13 is basically 2 times tan inverse of cos x. 2 times tan inverse of cos x is equal to tan inverse of 2 times cosecant x. So to basically to solve this equation, you have to take into consideration all the rules that you know from algebra and equations and everything, and moreover you need to also basically take all the rules of trigonometry into consideration. And whenever you want to do something, you need to understand it. Otherwise, I mean, for example, I'll show you, for example, one example in the same example here of what I mean. So we had a formula here that said that, for example, 2 times tan inverse of x is equal to basically the tan inverse of 2x over 1 minus x squared. Okay, so we had this formula that said 2 times tan inverse of x, because I want to get rid of this 2 over here. 2 times tan inverse of x is equal to tan inverse of 2x over 1 minus x squared. Okay, now so I can write this side of this equation based on this. I have 2 times tan inverse of cos x. 2 times tan inverse of cos x would be equal to tan inverse of 2x. 2x would be 2 times cos x, 1 minus cos squared x, right? So that would be this side of this equation. So I can write tan inverse of basically 2 times cos x over 1 minus cos squared x. And that is equal to the tan inverse of 2 times cosecant of x. Now, when you have the tan inverse of some ratio is equal to the tan inverse of some other ratio. Now, if you had, for example, the tan function, for example, if you had the tan of suppose that, for example, you have the sine of x is equal to the sine of y. Depending on the domain of the sine function, this could mean that x is equal to y, or this could mean that, for example, x is equal to, for example, pi by 2 minus y, or pi minus y, or something like that. Because there are different angles that you can enter into the sine function, and for all of those angles you will get the same value for the sine function. Meaning that depending on the domain of the sine function, first of all, you have to take into consideration the domain of the sine function, and we restricted that to negative pi by 2 to pi by 2. Right? The closed interval, negative pi by 2 to pi by 2. This is the domain of the sine function. Now, when I say that basically the sine of x is equal to the sine of y, if you take a look at this, usually using the unit circle you can solve such problems, or I can solve such problems much easier than using the formulas, because the formulas you have to remember them and you could make mistakes, but using the unit circle you can just see and understand. So over here, if I have the unit circle here, and suppose that, for example, suppose that I say that the sine of x is equal to, suppose that I say that the sine of x is equal to the sine of y. So what that means is that, for example, even going from negative pi by 2 to pi by 2, there are basically now, if you are working with the domain of the sine function, for example, then of course this can only mean that the cos that x is equal to y, because, for example, there is no way that you could get two angles in the first quadrant and in the fourth quadrant in such a way that their sine values are exactly the same. For example, I could go for example, 30 degrees and negative 30 degrees, right? And the sine of this would be, for example, 1 by 2. That is basically 30 degrees. And that is, for example, negative 30 degrees. And the sine of this would be negative 1 by 2. And of course you can see, and there is no way that you can get the same values for any two angles in these two quadrants if you're working with this domain. And basically 1 by 2 is not equal to negative 1 by 2, which means that basically sine x, which implies that sine x is equal to sine y, only means that x is equal to y. Now, if you go for example, there are some functions, some of these trigonometric functions, in the case of which you need to be careful, meaning that, for example, in the case of the cos function, for example, let's say that you have the cos of x is equal to the cos of y. And the domain of the cos function, we restricted that to 0 to pi, right? Now, if I say that 0 to pi means right over here. Now again, cos of x is equal to cos of y. The only way that we can, again, we get unique angles over here. But I do remember that there was at least one instance that I saw. For example, if you go for the tan function. For the tan function, for example, you have negative pi by 2 to pi by 2. For example, if you say the tan of x is equal to the tan of y, then the domain of the tan function is negative pi by 2 to pi by 2, right? Meaning that from here all the way up to here. Again, it's not possible. Or the cot function, if I say that the cot of x is equal to the cot of y, the cot is 0 to pi. 0 to pi, and cot is the same thing as cos by sine. Again, it's not possible. I don't know. I saw something before where when you say that the cos of x is equal to the cos of y or something like that, then it could mean that x is equal to y and also x is equal to, for example, pi minus y or something like that. I don't actually remember what that was. Now let's move on to the problem that we had. So the problem that we want to solve is basically so it seems that the only conclusion that I make here is that when tan inverse of some ratio is equal to tan inverse of some other ratio, it seems that the only logical conclusion is that the 2 times cos of x divided by 1 minus cos squared of x is equal to 2 times cosecant of x. Okay. Now what I can do here is that you know that basically 1 minus cos squared x is equal to sine squared x, because sine squared x plus cos squared x is equal to 1, and so 1 minus cos squared x is equal to sine squared x. 1 minus cos squared x is equal to sine squared x. So I can write this as 2 times cos x over sine squared x is equal to, now 2 times cos x, 2 times cosecant x. I can write it as, so you know that cosecant of x is equal to 1 over sine x. So that means that 2 times cosecant of x is equal to 2 over 2 times this, which is 2 over sine x, right? So I can write this as 2 over sine x. Now, you might be tempted to, for example, actually you can, in the numerator, you can simplify these 2's, meaning that you can just simplify these 2's, but the sine x in the denominator, what you would do is that you have, for example, 2 times cos x over sine squared x is equal to, for example, 2 over sine x. And then normally what you would do in equations, solving an equation, you would say that, you could say that, for example, I'm going to simplify one of the sine x's with one of the sine x's here, but that's not possible because the value of sine x in the denominator might become 0 for some value of x. Okay, for example, you know that for sine 0 is equal to 0. If I set x is equal to 0 in this equation, then sine 0 becomes 0 and this becomes undefined. And therefore, you're not supposed to do that. Meaning that even if you do that, then you have to say that basically x is not equal to 0. You have to write this condition here, and so that others know basically what to do with this equation and what not to do with this equation, right? That's what you know generally from solving equations, not just about the trigonometric equations. But you can cancel out these 2's from the numerator. There is no problem with that. So now what I can do is that I can say that basically I can cross multiply and say that sine x times cos x is equal to sine squared x. Sine x times cos x is equal to sine squared x. Or I can say that sine x cos x minus sine squared x is equal to 0. Now what this means is that if I take a sine x out and write this as cos x minus sine x is equal to 0, then if this whole expression is equal to 0, either sine x is equal to 0, or it means that cos x minus sine x is equal to 0. Now, if sine x is equal to 0, that means that x is equal to 0. And And if cos x minus sine x is equal to 0, that basically means that cos x is equal to sine x. Now cos x is equal to sine x is only possible if x is equal to pi by 4. Meaning that you know that basically the sine of pi by 4 is equal to 1, and also the cos of pi by 4 is equal to 1. If you cannot remember this, you can solve this equation in another way as well, meaning that you can say that cos x is equal to sine x, cos x is equal to sine x, and then, for example, divide by cos x. So cos x by cos x is equal to sine x by cos x, and cos x by cos x is equal to 1, and sine x by cos x is equal to tan x. And well, then x is equal to tan inverse of 1, and you know that the tan inverse of 1 is equal to pi by 4. So that way you can do that as well. So this means that x is equal to pi by 4, right? Now, you need to know which solution satisfies the equation. So either basically x is equal to 0 or x is equal to pi by 4, maybe both of them, maybe only one of them. So the equation that we had was basically 2 times tan inverse of cos x, 2 times tan inverse of cos x is equal to tan inverse of 2 times cosecant of x. 2 times cosecant of x. And what that means is that now if x is equal to 0, then cos of 0 is equal to 1. Right? Cos 0 is equal to 1. This becomes 2 tan inverse of 1 is equal to now cosecant of 0. Cosecant of 0 is basically 1 over sine 0, which is equal to 1 over sine 0 is equal to 0. This is undefined. So you cannot, this is actually not possible. That means that this is not possible. This makes the equation basically undefined. And if x is equal to pi by 4, what that means is that cos of pi by 4 is equal to square root of 2 over 2. Cos of pi by 4 is equal to square root of 2 over 2. So this is 2 times tan inverse of 2 times tan inverse of square root of 2 over 2. No, I'm sorry, cos of pi by 4 is equal to, cos of pi by 4 is equal to square root of 2 over 2. And that is equal to the tan inverse of basically cosecant of pi by 4. Cosecant of pi by 4 is equal to 1 over sine pi by 4, which is equal to 1 over square root of 2 over 2, which is equal to 2 over square root of 2. 2 times that would be 4 over square root of 2, would be 4 over square root of 2. And so here we had the cosecant of pi by 4 is equal to 1 over sine pi by 4. Sine pi by 4 is equal to square root of 2 over 2. 1 over square root of 2 over 2 is 2 over square root of 2. And if I multiply this by 2, I will get 2 times 4 over square root of 2. And this must be true, so that must be 4 over square root of 2. let's see if the equation is actually true. So basically, if I rationalize this, what I will get is that basically 4 over square root of 2 is equal to 4 square root of 2 over square root of 2 times square root of 2, which is 4 square root of 2 over 2, which is 2 square root of 2, which is equal to 2 square root of 2. So this is equal to the tan inverse of 2 square root of 2. Tan inverse of 2 square root of 2. Now, let's see if that's actually true. So we need to somehow rewrite 2 times tan inverse of square root of 2 over 2, and we had a formula for that. The formula was basically 2 times tan inverse of x is equal to tan inverse of this. So I'm going to attempt to write, basically, I know that 2 times tan inverse of x is equal to tan inverse of basically 2x over 1 minus x squared. So based on this, I can say that basically 2 times tan inverse of square root of 2 over 2 is equal to tan inverse of basically 2 times x, which is 2 times this becomes the square root of 2, and 1 minus basically this whole squared would be 2 over 4, would be 2 over 4, which is 1 over 2, which is the same thing as the tan inverse of, now 1 minus 1/2 is equal to 1/2. So that's, and square root of 2 over 1/2 is 2 square root of 2, and therefore 2 times tan inverse of square root of 2 over 2 is equal to the tan inverse of 2 times square root of 2, and therefore I can write, and therefore this becomes true, because tan inverse of basically square root of 2 over 2, this is equal to basically tan inverse of 2 square root of 2, and we got the same thing over here, which means that this is true, right? And you can see that algebra actually is a magical thing that does wonders for you. Okay, so that's basically one of these equations. Now let's do a couple more of these. Okay, so the next question that we have is question number 14, and you want to solve for x, and the equation is basically the tan inverse of 1 minus x over 1 plus x is equal to 1/2 the tan inverse of x for x is greater than 0. Now you know that basically the tan inverse of you know that the tan inverse of 1 minus x over basically 1 minus x over, we had the formula over here, hopefully somewhere. Tan inverse of x minus y over 1 plus xy. X minus y. Okay. Now we had a formula over here, and that is well, you can solve this problem this way, or you can do it another way as well, using algebra as well. If it's possible, then I'll show you both ways, but let's go with this solution for now. You know that basically, you know that the tan inverse of basically 1 minus x over 1 plus x, that you can write it as the tan inverse of so basically the formula that we have, which I'm not getting it right now, is the tan inverse of x minus the tan inverse of y is equal to the tan inverse of basically x minus y over 1 plus x times y. Which means that basically I can write this as, which means that the LHS, which is the tan inverse of 1 minus x over 1 plus x, I can write it as basically the tan inverse of 1 minus x over 1 plus 1 times x, right? So I can write it this way, and therefore I can write it as the tan inverse of based on this formula, I can write it as the tan inverse of 1 minus the tan inverse of x. So basically, so then I can write this side of the equation, I can write it as the tan inverse of 1 minus the tan inverse of x, and then that is equal to 1/2 tan inverse of x. And then what we can do is that you can, tan inverse of 1 is equal to pi by 4. And so if I take this to the other side of the equation, that gives me 1/2 tan inverse of x plus tan inverse of x. And that is basically 1 plus 1/2 is 3/2. So that is 3/2 tan inverse of x. That is equal to pi by 4, which means that basically the divide, if you simplify, basically 2 by 2 is 1, 4 by 2 is 2. That means that 3 times tan inverse of x is equal to pi by 2, which means that tan inverse of x, which means that the tan inverse of x is equal to pi by 2 divided by 3, which is equal to pi by 6. If the tan inverse of x is equal to pi by 6, then x is equal to basically, you know that basically the tan inverse of x is equal to pi by 6. That means that x is equal to tan of pi by 6. Tan of pi by 6 is equal to basically sine of pi by 6 by cos of pi by 6. So sine of pi by 6 is equal to 1 by 2, cos of pi by 6 square root of 3 by 2. And that's the same thing as 1 over square root of 3. Which means that basically x is equal to 1 over square root of 3. Okay, so that is the answer here. There is one more way to solve the same problem, and that is if you basically solve the problem this way, meaning that you can, instead of using the formulas, you have the tan inverse of 1 minus x over 1 plus x, which is equal to 1/2 the tan inverse of basically x for x is greater than 0. This takes a little bit of work, but it's possible. So you can write this as, if I multiply both sides of this equation by a factor of 2, you'll get the 2 times tan inverse of 1 minus x over 1 plus x is equal to 2 times 1/2 is equal to 1, so that is tan inverse of x. Now, I don't really remember how I did this. Then what you can do is that, you know that the tan inverse 2 times, we had a formula here, and we said that basically 2 times tan inverse of x is equal to tan inverse of basically 2x over 1 minus x squared. So I can rewrite this, because I'm doing this because I want to get rid of this 2. So I can write this as the tan inverse of, based on this formula, 2 times x would be 2 times this thing over here, which is 2 times basically 1 minus x over 1 plus x, and the denominator becomes 1 minus x squared. So 1 minus this whole thing, 1 minus x over 1 plus x whole squared, which becomes basically numerator squared divided by denominator squared. And that is equal to basically the tan inverse of x. Now the tan inverse of this expression is equal to tan inverse of x, which means that basically this expression is actually equal to x, which I can write basically 2 times 1 minus x over 1 plus x over basically 1 minus x whole squared over 1 plus x whole squared is equal to x. And then we can simplify this part. Which is basically, I can write this as 2 times basically 1 minus x over 1 plus x, and then I can write it as basically take LCM as 1 plus x squared, and write 1 plus x squared minus 1 minus x squared, and then I can simplify basically the denominators, meaning that 1 plus x and 1 plus x I can simplify, and then here I should say that basically I should say that 1 plus x squared is not equal to, or basically I should say that 1 plus x is not equal to 0, because I'm removing this from the denominator. And I should say that 1 plus x squared is actually, that is enough. So 1 plus x is not equal to 0, meaning that x is not equal to -1, which is of course already the case because we are talking about x is greater than 0. So then I have 2 times 1 minus x over this fraction, which is the same thing as this expression times the reciprocal of this. So the reciprocal of this would be 1 plus x times basically this numerator here, which is 1 plus x squared minus 1 minus x squared, and that gives you basically this is a minus b times a plus b, which is equal to a squared minus b squared. So that gives you 2 times 1 squared minus x squared, so 1 minus x squared, and this is actually this is supposed to be, this is not right. This is supposed to be 1 plus x squared, 1 minus x, 1 minus x whole squared. So that becomes basically 1 raised to the power 2, 1 plus x squared plus 2x minus 1 squared, which is equal to 1 minus plus x squared minus 2x, right? And that's the same thing as basically 2 times 1 minus x squared, 1 plus x squared plus 2x minus 1 minus x squared plus 2x. And then these two you can cancel out. These two you can cancel out. You have 2 over 1 minus x squared over 4x. And then you can cancel these two out. You have 1 minus x squared over 2x. You have 1 minus x squared over 2x is equal to x. Now if you cross multiply, you'll get 2x squared is equal to 1 minus x squared. Or you can say that 2x squared minus 1 plus x squared is equal to 0. Which means that 3 times x squared minus 1 is equal to 0. Which means that 3 times x squared is equal to 1, which means that x squared is equal to 1/3. And since we're talking about positive x is equal to the square root of 1/3, which is equal to 1 over square root of 3, which is basically the answer that we got before. But this does need a little bit of algebra. The other solution actually does not need any algebra. Okay. So that was question number 14. That was question number 14. Now question number 15. Question number 15, we have basically it's another equation that we need to solve. Okay, so the next question that we have is the sine of tan inverse of x. Question number 15. The sine of tan inverse of x for basically the absolute value of x is less than 1 is equal to basically choice A is x over the square root of 1 minus x squared. Then you have choice B, which is 1 over the square root of 1 minus x squared. Then you have choice C, which is 1 over the square root of 1 plus x squared. And choice D, which is basically x over the square root of 1 plus x squared. Okay. So now you can solve this problem. Basically you have the sine of tan inverse of x, right? So if you want to evaluate this, you have to write it somehow in the form, for example, sine inverse of something, for example, y, and then that would be equal to y, provided that y is in the domain of the sine inverse function, meaning that provided that basically y belongs to -1, the closed interval -1, because that's the domain of the sine inverse function. Now this So you need to do something like this, meaning that you need to write tan inverse in terms of sine inverse, right? So in order to do that, we had a formula, and that formula was basically, of course, there is some problem here that I don't really know much about these formulas, meaning that I have not been given enough information. I'm just using them just like that. And this is, technically, this is not right. You need to know basically where to use your formulas, where not to use them, and you need to know the domain and ranges and everything. But as long as you're just working with the formulas, that doesn't really matter. So we had a formula that we said that basically the tan inverse of A by B is equal to the sine inverse of basically A over the square root of A squared plus B squared. Okay, so we had this formula. Now, since I want to write tan inverse of x in terms of sine inverse, I can say that basically based on this formula, the tan inverse of x, I can write it as the tan inverse of x divided by 1, meaning that A becomes x and B becomes 1. And so then I can write this as the sine inverse of basically A, which is x, over the square root of A squared plus B squared, which is 1 plus x squared. 1 squared is equal to 1, right? And then I can write this as basically the sine inverse of x over the square root of 1 plus x squared, which I can write as x over the square root of 1 plus x squared, and that is provided that basically x over the square root of 1 plus x squared belongs to the domain of the sine inverse function, which is negative 1 comma 1, which means that basically this has to you can say that x over the square root of 1 plus x squared has to be anywhere between negative 1 and positive 1, and there is equal to as well. Now, I suppose if you solve this inequality, you must get, or you should get, that the absolute value of x is less than 1. You should get the absolute value of x is less than 1. You should get this. And the meaning of this is, basically, between negative 1 and positive 1, right? That's the meaning of this. Now let's see if that's actually the same thing. So if I divide by, for example, if I multiply by the square root of 1 plus x squared, I'll get negative square root of 1 plus x squared is less than or equal to x, less than or equal to the square root of 1 plus x squared, right? And what that means is that I somehow need to get rid of this. Get rid of the square root function, which means that I raise this to the second power, for example. And if I raise this to the second power, I will have basically negative square root of 1 plus x squared whole squared is less than or equal to x squared is less than or equal to the square root of 1 plus x squared whole squared. This whole squared. which gives me 1 plus x squared is less than or equal to x squared is less than or equal to 1 plus x squared, which makes no sense. Now that doesn't make any sense. Now anyway, the condition is that, let me see if I did this right. So over here we are saying that this has to belong to this domain, to this interval, which means that -1 is less than or equal to this, is less than or equal to 1. Now I can multiply by the square root of 1 plus x squared, so that becomes negative square root of 1 plus x squared, this becomes x. And so if I raise this to the second power, I will get 1 plus x squared less than or equal to, and then this is, of course, has to be raised to the second power as well, which I have already done. Well, this doesn't make any sense as far as I can see, but what we got over here, I don't really know about anything about the domains and the ranges, the exact domains and ranges of these formulas and of these, basically all of these formulas. So this kind of thing is normal and natural as long as you don't know what you're doing. Meaning that sometimes, for example, you're not supposed to use one of these formulas in a particular situation, and you do that and you get into logical problems. But the answer that we got was basically the x over the square root of 1 plus x squared, which is basically choice D here. And well, based on this problem, choice D is the right answer, is the correct answer, and that's basically all that we care about right now. When we get into basically higher mathematics, then we will investigate all of these problems. These problems are a necessary part of learning. There is no other way to learn mathematics really, because if they want to tell us about basically everything right now, then of course it would simply be impossible. So it's just not practical or possible. Now question number 16. Question number 16 is basically the sine inverse of 1 minus x minus 2 times sine inverse of x minus 2 times sine inverse of x is equal to pi by 2. Then x is equal to a 0, 1 by 2. B would be 1, 1 by 2. C would be basically 0, and D would be 1 by 2. So if sine inverse of 1 minus x minus 2 times sine inverse of x is equal to pi by 2, then x is equal to which one of these options? Okay, so now in order to solve this problem, question number 16, so what you can do, I did have to go through this problem twice, but now we will do that together. So what you need to do is that, so you have basically the sine inverse of 1 minus x minus 2 times, and of course this is the right answer, but then we will know that in just a few moments. Minus 2 times sine inverse of x is equal to pi by 2, then x is equal to which one of these choices? In order to solve the problem basically since you have the sine inverse of 1 minus x minus 2 times sine inverse of x is equal to pi by 2, let x be equal to sine of y, which means that basically then one becomes the sine inverse of 1 minus sine y, 1 minus sine y minus 2 times sine inverse of sine y is equal to pi by 2. Now, this means that the sine inverse of 1 minus sine y. Now sine inverse of sine of y is equal to y, so that's negative 2 times y is equal to pi by 2. Then you can write this as, then you can take negative 2y to the other side and write this as the sine inverse of 1 minus sine y is equal to pi by 2 plus 2 times y. Okay? And if I take the sine of both sides of this equation, meaning that if I write the sine of, basically the sine inverse of 1 minus sine y, and write this as equal to the sine of pi by 2 plus 2y, that is going to be equal to the sine of sine inverse of 1 minus sine y is going to be equal to 1 minus sine y, and the sine of pi by 2 plus 2y is basically, you know that the sine of pi by 2 plus x is equal to cos x. So this would be equal to the cos of 2y, right? So 1 minus sine y is equal to cos 2y. Now cos of 2y, I can write it in terms of sine because I know that cos 2x is equal to okay, so cos of 2x is equal to 1 minus 2 times sine squared 1 minus 2 times sine squared x. That means that basically I can write this as 1 minus 2 times sine squared y, and that is 1 minus sine y. And then what I can do is that simplify basically 1 and 1 from both sides of this equation. Negative and negative you can simplify, and so you have 2 times sine y minus, basically you can write sine y minus, take this to the other side of the equation, 2 times sine squared y is equal to 0, which means that then you can write this as sine y, take that out, 1 minus 2 times sine squared y is equal to 0, right? Now this implies that either sine y is equal to 0, or basically 1 minus 2 times sine squared y is equal to 0. And here you can basically substitute back, since x is equal to sine y, you can just simply substitute x back, meaning that you can write, instead of using this, then because it gets unnecessarily complicated, sine y I can write it as x because well, sine y is actually equal to x, And then 1 minus 2 sine squared y is basically 1 minus 2 times x squared is equal to 0. That means that either x is equal to 0 or 1 minus 2 times x squared is equal to 0. This means that negative 2 times x squared is equal to negative 1, which means that 2 times x squared is equal to 1, which means that x squared is equal to 1/2, and then x is supposed to be 1 over square root of 2. I think I've made a mistake over here. So over here I have 1 minus sine y is equal to 1 minus 2 sine squared y, or basically, oh, I have made a mistake here, I'm sorry. I made a mistake here. So here I have, if I take the sine y out, I will get 1 minus 2 times sine y is equal to 0. Now sine y is equal to, since sine y is equal to x, I can write x times 1 minus 2 times x is equal to 0, which means that either x is equal to 0 or 1 minus 2 times x is equal to 0, which means that negative 2x is equal to negative 1, which means that 2x is equal to 1, which means that x is equal to 1 by 2, right? So now you need to basically test these, solutions. To test these solutions, what you can do is that the equation that we had was basically sine inverse of 1 minus x. We had basically sine inverse of 1 minus x minus 2 times sine inverse of x is equal to pi by 2, right? Now if I set x is equal to 0, I will have the sine inverse of 1 minus 0, which is equal to 1, minus 2 times sine inverse of 0 is equal to pi by 2. Now sine inverse of 1 is equal to pi by 2. Now sine inverse of 0 is equal to 0, so negative 2 times 0 is equal to pi by 2, which means that pi by 2 is equal to pi by 2, which is true. And so basically x is equal to 1 by 2 is a solution. I'm sorry, x is equal to 0 is a solution. On the other hand, if I say that x is equal to 1 by 2, this equation becomes the sine inverse of 1 minus 1 by 2 is 1 by 2, minus 2 times sine inverse of basically 1 by 2 is equal to pi by 2. Now sine inverse of 1 by 2 is basically pi by 6 is equal to pi by 6 minus 2 times, again, 2 times pi by 6 is equal to pi by 2. And this would be pi by 3, so pi by 6 minus pi by 3 is equal to 6. So that is pi minus 2 pi is equal to pi by 2. And then that is negative pi by 6 is equal to pi by 2, which is not true. Therefore, x is equal to 1 by 2 is not the solution. and x is equal to 0 is a solution, which means that choice C is the correct answer, right? So that is basically, that was question number 16. There is one more question left here, so let's do that as well. Let's see what we have here. So basically you have the tan inverse of x by y. This is number 17. So you have the tan inverse of x by y minus the tan inverse of x minus y over x plus y is equal to A pi by 2, B pi by 3, C is pi by 4, and D is negative 3 pi by 4. So we know that basically tan inverse of x minus tan inverse of y is basically, we know that tan inverse of x minus the tan inverse of y is equal to the tan inverse of basically x minus y over 1 plus x times y. But then this would be very this would involve a lot of algebra, which seems to be the only solution here, so we'll have to do the same thing. Okay, so now let's calculate basically x minus y over 1 plus xy. Now x would be, in this case, x by y, and y would be this expression. So I write basically x by y minus this whole expression, which is basically x minus y over x plus y, and then 1 plus basically the product of these two, which would be x times x minus y over basically y times x plus y, right? So this is equal to you can take the LCM here as y times x plus y, and you would have basically x times x plus y minus y times x minus y, and then you would have over here, you would have the LCM as y times x plus y, and then you would have y times x plus y plus basically x times x minus y. And then you could cancel these two out and simplify. To simplify, you could write x squared plus xy minus xy minus y plus y squared, and the denominator becomes xy plus y squared plus x squared minus xy. So then you can cancel these two out. You will have x squared plus y squared over x squared plus y squared, which is equal to 1. So this becomes basically this basically the LHS of this expression becomes basically the tan inverse of 1 is equal to which is equal to basically tan inverse of 1 is equal to basically pi by 4 is equal to pi by 4, and that is basically C is the correct option, right? So that basically concludes chapter 2 of the book. This was chapter 2. Now chapter 3 of this book is about, this was basically NCERT mathematics class 12 part 1. This was chapter 2. This was chapter 2. Now chapter 3 is about matrices. So in the next basically I will create a playlist on YouTube, and then we will upload all of these all of the videos related to matrices on YouTube. So I'll see you in the next courses to come. Thank you for watching, and I'll see you in the next courses. Thank you.